G'day everybody, WheresWally here. Well, David Weiss, you asked for proof of a globe, and by that I assume you mean that the Earth is a basic sphere shape. Anyway, what follows is a measurement of r, the radius of the globe. I think you'll find this meets your requirements for your challenge for the 3 Bitcoin. Now, you won't be able to debunk it either, so just sit back and relax. This won't take long. Oh, and speaking of failure to debunk, I took the liberty of running this proof past Nathan and his crew the other day, and, well, they were totally unable to debunk it.
You get it, Wally.
The measurements aren't subject to just rotation or effective curvature, because what they're not measuring is stars, which are off into infinity in their model.
Oh, you really want me to use the background stars then? They are right there, you know. Are you really sure? Because none of this has worked in your favour yet, has it?
That's perfect. Therefore, at this point, full stop, you've debunked it.
Well, no, you haven't. I just pointed out that all your debunk points are all bunk, and I'm still undebunked.
You get it, Wally.
For the initial premises, which was highlighted by Mitch in the first place, they need to beg the question and assume they're standing on a spherical surface to derive any of these nonsense chords that don't match the arc lengths and have a geostationary satellite utilization, when in fact, to beg the question in the first place, you must push the distance out to infinity for those stars, which you're not doing, giving you a 25% error.
You're wrong.
So it's a complete balls up. I mean, it's a complete sham. One more point. One more last point. They can't even measure the angle on a globe.
Totally unable to debunk it at all. And they tried for several hours. It was like watching a flock of flapping, squawking seagulls after a non-existent chip. Desperate to be the one to devour it and remove this evidence from before them, it was rather hilarious to watch. They tried the usual begging the question, assuming the globe type nonsense, but as you'll be saddened to see, David, that never actually happened. In fact, the only question begging I do is assuming it's flat. And that didn't work out real well. R-Proof version 3. On September 24, 2021, I hired a telescope in Dubbo, Australia. Wolfie was in Sydney also, and he got out his good telescope that night too. We pointed them both at a group of geostationary satellites over the equator, well, naturally, and their GPs are roughly 0 and 109.8666 longitude. Well, both telescopes observed this group of eclipsing satellites in turn as they entered the Earth's shadow, as this was midnight 2 days after the equinox. So these satellites, they reappeared exactly 1 hour, 7 minutes and 34 seconds later. So taking the frame from both Uber sextants at exactly the moment when the satellites entered the shadow at 1:58:08 AM local time, I was able to get simultaneous sightings of the same satellite from 2 different locations. Fact A, the 2 Uber sextants were measured on Google Maps to be 281.91 kilometers apart. That's not disputable. Fact B, you can see the same grouping of satellites, and you can even see the same stars passing behind them, although there is parallax there, obviously. Fact C, taken at the same time as you can see the geosats go dark in both telescopes, so we know that it's the same time. And the timestamps from both telescopes are within a few seconds as well. Fact D, the pointing data from each telescope is given, the azimuths and the alignments are all within 1 degree, so we can pretty much ignore those and treat this as a 2D problem and use Muppet View to explain this proof. Fact E, I used plate solving to verify the telescope pointing angles as well. Plate solving is sort of astronomical almanac, if you will, and it's super cool. The difference between the right ascension values also tell me the angle between the 2 lines of sight is just 0.074 degrees. The 2 elevation values are how far above the horizontal plane the sight lines are. This horizontal is derived from the stars themselves, and it's amazingly accurate, and it matches the local horizontal precisely. I also noticed that the Sydney image was not quite centered on the frame like the Dubbo image was, and by counting pixels I worked out that it was 0.2570 degrees of frame shift, which I corrected for. Now this image here on the screen is only the measured facts, so what does all this mean? Well, I added the difference in the elevations to the frame shift correction and the difference in the right ascension values, and it seems that the level in Dubbo is 2.5979 degrees different to the level in Sydney. If the horizontal planes are not coplanar, then the verticals cannot be parallel, and if they're not parallel, then they might just converge. So the verticals at Dubbo and Sydney are 281.91 kilometres apart at the uber sextants. That is the arc distance, but the chord distance is a mere 23 metres different. So that's good enough for me. It changes nothing. They diverge upwards, so they must be converging downwards. So now we have an isosceles triangle with a base of 281.91 kilometres and the acute angle of just 2.5979 degrees. It is simple maths to solve that, just to work out that the two large angles, which are the same and are 88.701 degrees. Now a little bit of law of sines, and voila, the length of the two sides of the telescopes to where the verticals converge. Now that we have a point of convergence, you want to buy a vowel? Only costs 3 Bitcoin. So I measured the R as 6218 kilometres or 3684 miles. Now that's just 2.5% from the accepted value. Not bad at all. At one point, Nathan and the Adam Meakin did mention, and little Mitchell too, I think, that maybe I should have used the background stars instead of the geostationary satellite. So as a consolation prize to them for not being able to debunk version 2 of the R-proof, I thought I would add a whole new version 4 of the R-proof, this time using the star called ND218853. Enjoy this R-proof, David. It's not going to cost you an extra 3 Bitcoin. I mean, I'm not going to pull a Mitchell on you. Here we go. R-proof version 4. The Star of R. Bonus round. To keep it super simple, I have used the exact same frames as I did last time. One from each telescope. The Dubbo image was captured on the 24th of the 9th, 2021 at 15:58:08 UTC, and Wolfie's was captured a mere 12 seconds before that. Remember that fact. The first thing I did was to measure in degrees just how far the star was from the center line of the frame in the right ascension axis direction. The target star was close to both images, but I wanted the most accuracy possible. So I adjusted the right ascension according to the values I just calculated here. Next, I realized that because the telescopes were not tracking, the star was moving across the frame. As you can see here, when I superimpose the star from the previous frame, it is quite a bit further to the right 31 seconds earlier. However, I needed to adjust for just 12 seconds of difference. The simplest way to do that is to use the fact that one sidereal day means the star will be back in exactly the same position in the sky. So I simply divided 360 degrees by 86,164 and multiply that by 12 to get 0.0501 degrees of error, which I added to the Dubbo scope as it was 12 seconds behind Wolfie's, which meant the position of the star had moved just 12 seconds too far to the west. That makes the total angular difference of 2.4892 degrees between the two local horizontals at each telescope. So from this point onwards, the method is identical to the previous proof. I now have an isosceles triangle with a base of 281.91 kilometers, and the opposite angle is 2.4982 degrees. Now, when solved geometrically, that inverted triangle has sides of length 6,466 kilometers or 4,018 miles. That figure is slightly longer than the generally accepted average value of R, but now that you can see that I've measured the radius of the Earth, then the fact that there has to be a sphere of radius R, it is so obvious that even a 5th grader could point it out to you, mate. So if you're really struggling to understand just what's going on here with these two horizontals that are now not coplanar, It's quite simple. If you imagine that both sight lines have a very narrow angular separation, which means they're virtually following the same path. So then if you draw the horizontal crossing it at Dubbo, and then go 281 kilometres further along it and draw the horizontal at the elevation angle at Sydney, you'll find it's about 2.4 degrees more acute, which means the horizontal in Sydney is tipping away at about 2.4 degrees. It is that simple, really. So there you have it, the radius of the Earth, measured twice, first time to within 2.5% of the generally accepted average value of R, the second time to less than 1.5%. And this is very close, considering that the Uber sextants were very close to each other. Now imagine how much better this will be when Wolfie and I do it again from opposite sides of Australia, with him in Perth and me in Dubbo. And we are going to do that the very next chance we get. So to help you out here, David, I'm sure you're feeling a little bit faint right about now. Here's my Bitcoin wallet address. Just pop the 3 Bitcoin in there and we're done, mate. Now, there's no need to claim that you don't have my 3 Bitcoin. Mitchell assures us all that you do. Have a listen.
Yeah, DITRH claims to have 3 Bitcoin to give out, but doesn't own 3, so how's he different to Mr. Sensible? Well, DITRH absolutely has 3 Bitcoin. Come on, man. He's very, very open about him being Jewish. He definitely has money. He definitely has 3 Bitcoin, and he wants to give it away to anyone who can give us just 1 flat earth proof.
Oh, Mitchell, that was more than just a little Freudian, wasn't it? I might have to put that in the sound file. So thank you, David. It has been a pleasure. I look forward to watching my video on your sun, moon, star, eclipse clock app thingy. It will be a little bit better than all the other flat earth derpy stuff I've been putting up with for the last couple of weeks. I will be back though. I have about 20 more of these globe proofs for you, mate. So Dave, I'll let you have the last word.
You're going to need R for that.
Yeah, from DITRH.
Oh, you know what? Every time you've chanted that, I've actually got half of that now, mate. Sorry, not sorry. Thanks, David. This has been fun. Well, that was rather easy. What can I do now? Maybe I'll see if I can prove black is white, right after I go and cross the road here.